There are spaces left on the front row. It's like in school, nobody wants to be on the front row. Okay, let's start. Yeah, actually that's true. You never should be at the front row in a cinema. Welcome in this session. I have to start with a disclaimer, and that the CRaC that I will be talking about is coordinated restore at checkpoint, because yesterday at the speaker dinner, I was talking about this subject, and I was talking about distributing CRaC and using CRaC. So it's not a medicine, okay? I will also explain you why this chart is important and what you can learn from it, and we'll come back to that, and how CRaC can help you to make your application start a lot faster. These are not final results, these are results from a test we did in the early phase of the project. But I actually will mainly talk with you about OpenJDK, about the project where Java lives. But I have to give you some history to understand my story, the story that I want to tell you today. Actually, I started programming when I was 11 years old with this computer, so that can give you an estimation of my age. And what was amazing at that time already with that computer was that I was able to combine software and hardware. I used the relay board, by a Dutch company, by the way, to control my Lego train. And through the joystick port of my Commodore, I could know where my train was because of magnetic switches. So already at that time, I was experimenting with the combination of hardware, software, electronics, embedded computing, if you can call it like that. Now, I have taken a bit a strange path. I think most of you here are software engineers. I actually did film school. And it's very strange to be in a cinema. I am a film editor, but I ended up in a cinema with a talk about software. I never reached this goal with a film project. Now, because I'm a bit of age, I went through this whole evolution, and I've seen a lot of different technologies, but I'm, again, not an educated programmer. I just stumbled into this, and at some point I ended up using Java and entering that world of open source and how people are sharing their knowledge and the things that they are making, and I became a Java user without really knowing what is happening inside, how this project is created and evolves. Now, 4 years ago, I had this wild idea of creating this touchscreen thing for the drum boot of my son. And I was using Java, so I wanted to learn again the electronics that I was using as a kid. How can I do this with nowadays technology like a Raspberry Pi, Arduino, and combine all these things? And so I started experimenting, and yeah, then I ended up with this project, and because it's Java, there is an API, so we can inform our son that dinner is on the table and he has to stop drumming. To be honest, this video is 4 years old. That little boy is now twice that size. And there are a lot more posters in that drum boot, but the project is still there. So this was my experimentation board. I was experimenting with Java on a Raspberry Pi, on embedded, trying out different things. You have this little segment display you see at the bottom that you know from your alarm clock. So for 6 months, this was the 4th member of our family, and I was doing experiments with Java on that Raspberry Pi, and that's how I ended up writing a book. I'm the king of bad timing, so it was published just a month before COVID, before I could do conferences. But this is my journey through Java and how I combine that with electronics and embedded. And why I'm telling you this story, because since then I am the Java on Raspberry Pi guy, the hashtag. That's my niche product. That's the thing people know me from. And the book also led to another evolution. Suddenly I became part of the Azul team. And Azul is one of the many distributors of OpenJDK. We build distributions of OpenJDK. People may know us from Azul Zulu, which is part of the core product. Zulu is one of that Java distributions that is used a lot because it's free. It has all the latest versions and releases and updates and stuff like that. And you can get support if your company needs that. Now, we also have Azul Platform Prime, which is based on OpenJDK, but it has some other tools. So it has another garbage collector, an extra garbage collector, I should say. It has another compiler. So there you see that there are different products built based on top of OpenJDK. And because Azul is a company oriented to Java and Java only, we have some other products like vulnerability detection that we can inform you that there is a vulnerability in your system, or even in applications that you're running on Java within your environment. Like for instance, if you're using Kafka and there would be some vulnerability in there, we can inform you about this. Now, The State of Java is a book we just released, a report. If you're interested in this, you can find it on our website, and you can talk to my colleagues who are at the booth at the exhibition hall. So this evolution, I am still a Java developer, but I became part of the team who creates Java. And that was an eye-opener for me. I was a Java developer. I knew Java. I knew how to use the code, but I didn't know the project, what's happening within that project, what's evolving within Java. And that's how I gained insight into how the OpenJDK project is managed and how things evolve in there. And along the journey, I even became a Java champion, and I still cannot believe that happened, to be part of that team. So I want to share some things that I learned in this past 1.5 years about OpenJDK and stuff which are happening and evolving in there, like the CRaC stuff. One tip I can give you, you will see a few screenshots where I show Java versions that I'm using. Who knows SDK-man? Okay, that's already quite some people. It's a very handy tool to switch between Java versions, even if you just want to test with a newer version or an older version. It's very easy to switch between versions and help you there. Now, there's one thing you need to understand, and that's the difference between Java and OpenJDK. Java is a trademark. Java is, someone owns this. Oracle owns the name of Java. But Java is the programming language also. And what's more importantly, Oracle defines the TCK, the Technology Compatibility Kit. Everyone who distributes OpenJDK has to ensure that it's compliant with this kit, so that you as a Java programmer, you create an application, if you execute it on Azul Zulu or on any other build from Microsoft, from Submachine, from Belsoft, from all the others who are distributing OpenJDK, they all have to be compliant with this kit, that you as a developer are sure that your application will behave exactly the same, independent of which Java distribution you're using. And OpenJDK is actually the implementation of the Java. And OpenJDK lives on GitHub. So you can take a look at the sources. You will find everything there that's related to the programming language, to the JVM, to the libraries, and it's free to use and modify. So you don't need to use a distribution from one of the many companies. You can create your own. And that's a fun thing I will show you. Now, OpenJDK, this is a bad screenshot. This is the OpenJDK project on GitHub. Some of the project, there are many more. The one which is important is JDK, the third one on the top. That's where the JDK lives. But there are more there, and even CRaC is at the bottom. CRaC is a project within OpenJDK. As I said, you can build your own JDK. That's what I've done, for instance, on the Raspberry Pi. If you want to experiment with Java and how OpenJDK works, then building your own version is a nice thing. So you see, my Raspberry Pi has version 21 installed. It's Azul Zulus with CRaC. But in another directory, I downloaded OpenJDK and compiled it. Okay, it took 1.5 hours on my Raspberry Pi. But after that, I can run the latest build, and the latest build is 22. Because now they are working on Java 22, which will be released soon. So you can get the latest version, compile it yourself, run any Java application, like I did Java version, is actually executing Java. It gives you the information about the latest build. Now, there's a big difference between upgrades and updates of Java. If you do an upgrade, that means that you bump your major version. We have all done, I hope we are all on 21 by now. But there's one more thing which is more important, and that's the updates. If you have installed Java 17 at some point, months, years ago, do you know which one it was? Which 17 that you installed? Because every 3 months, there is a new 17. There is a 1701, a 1702. And each version comes with bug fixes, but more importantly, comes with security fixes. So if you're still on that initial version of 17, you are missing a whole evolution of what happened in there and improvements that have been done. Who is on Java 17 in production? Oh, well, that's a nice number. Do you know which version of 17? Which update? Any idea? Okay. Because this is the list of Zulu version 17. I think it's on my Mac that I've taken a screenshot, but it doesn't matter. So we are on 1709. So we are already 9 times that there has been applied, security fixes has been applied to 17. Okay? If you look at the release notes, by the way, this is my work. This is why I live together with my colleague. We are maintaining this. If you're looking at the release notes of October, so I say every 3 months there is a new thing, and we go to the security fixes. So in October, 3 issues were fixed related to security. And some have a base score of 5, so the score is between 0 and 10. How dangerous it is, how easy to exploit, and stuff like that. So that was only in October. If we go to July, a little bit more. So I've only taken 2 of these 9 versions of updates which were released. So all these contain security fixes. Okay? So keeping your runtime in production up to date is a very important thing. And if you're running Java 17, do you know which distribution you are using? I see a few people. Okay. Most people say it's OpenJDK. Yes, it's OpenJDK, but that's not the distribution. That's where the sources live. The distribution is, it's Azul Zulu, it's Belsoft, it's Amazon, it's whatever. So you have this whole list. If you want to update to this version 1709, that's the list you can select from. There are many of there. And they have one thing in common, they are TCK compliant. But that doesn't mean that they are the same. I just did some interviews, and one of my guests said, we are doing energy tests to see which distribution uses the most energy for the same tasks. So even how much energy your system is using can be defined by the distribution you're using. Too much to cover in this talk. Simon Ritter, our CTO, has written this Dummy for Dummies book. It's pretty technical, so the for dummies, we can debate that. It's for free. You can download it. Just check the Azul website. It gives you more insight about what is a Java version, a distribution, why it matters, why you have to select certain of these, depending on if you want support, if you don't need support, stuff like that. Okay? This is a fun story I discovered while writing the release notes of Azul Zulu. Did you know that there is a whole database inside OpenJDK with time zone and currency data? Of course it is. And it has a big impact. Who uses JShell? Come on, just open your PC and try it out because it's a very fun tool. Just a few lines of code and you can find things and experiment with things. There are 603 time zones IDs in that database. And if you go into the project on GitHub, it's like reading a history book. That's a whole story about what happened in Belgium. Yeah, I'm from Belgium. What happened in Belgium, when time zones changed, when daylight savings changed. Hopefully, one day we will have the end of time zones in there. No, daylight savings. Time zones would be a bit ridiculous, but daylight saving. But there is a whole history in here. And you can just read it. These are text files. How did I stumble upon this? Because every time, every 3 months in the release notes, we say this version of Azul Zulu has the time zone database version something. What is this? Where does this come from? Now, Ayana seems to be a website where they have a central place to keep track of all the changes in time zones. And there you see 2022G. And all the changes within that project are ported or copied into OpenJDK. And if you look into the release notes of January 2023, you see that there are 3 JDK tickets related to changes in time zones into country data. Like, for instance, the currency changes for Croatia. Now, why is this important? If you run this JShell code with version 1901, and you ask for the currency in Croatia, which is the code HR, then you get the Croatian kuna. Okay? This is your system, it's running on 1901. Now you do a security update and you go to 1902, and suddenly all your systems are failing, or your unit tests are failing, because instead of, for the same country, it returns euro. Because Croatia joined the euro thing. So nothing changed in your code, but suddenly you know that for Croatia, this is the currency. So it can have an impact on your unit test, it can have an impact on your application. But actually, you did nothing wrong. OpenJDK did nothing wrong, it's just the environment changed. So knowing what version you are using, knowing that you need to update and what can happen if you update, is part of the OpenJDK project. By the way, I'm one of those people who cannot exit Vim. If you cannot exit G-Shell, that's the thing you need to know. Okay? Now, a long story to tell you that not all distributions of Java are the same. Like, for instance, Azul Zulu is available in a few different flavors. We have flavors with JavaFX, but we also have flavors with CRaC in them. So they have the CRaC project in them. We have this for Zulu 17, originally only for x64 processors, now also for ARM, and for 21. Now, what is CRaC and why is it important? I hope this is clear for all of you. If you write your Java code, that's not the code that you're going to execute. Your Java code needs to be compiled into bytecode, and the bytecode is the thing that is designed to run on different platforms. Oh, yeah, join. The bytecode is the code that can be executed on different platforms by Java. So Java will take this compiled code and execute it. It is meant to be executable on different platforms, on different processors. And that's an important thing. That made Java write once, run anywhere. But it comes with some consequences. That bytecode is not optimized for the platform it's running on. So when you're executing code, and actually as a Java developer, I was not aware of this. If you execute your code, the bytecode, the class file, you are in the yellow zone. And the performance is not ideal. It just executes the code that you have written in Java. And it starts counting in your code how many times has this been used. And above a certain threshold, it decides, now this is important code, I need to execute this a lot, let's see if I can optimize it. If I can make native code out of this, but as fast as possible, that I can speed up the application. So you end up in the green zone, and your application performs better and better. And again, it starts counting how much time the code is used, but also how the code is used. So imagine you have a switch with 5 cases, 2 are never used. So we'll just drop those 2 and optimize the other 3 and have some kind of error handler for the 2 others that in case they ever are needed, it can go back and do it again. And that's when the blue line starts appearing. And the drops you see in the beginning is when it made an assumption, this code is not needed. Oh shit, it is needed, so let's recompile it. So you have a little performance drop. And at the end, the drops is the garbage collector kicking in. So but at some point, warm up, you reach an optimal state and your application behaves as best as at best level that it can be. So you have this whole cycle. You start with interpretation, the bytecode. It starts finding the hotspots, what is used the most. It compiles it, but fast, with low optimization. Then it profiles it again, and then it comes into the best possible native code for your platform, that operating system. This is the most optimal code that I can use. And if it made a wrong assumption, it will do it again. Now, what is a solution to avoid this warm-up is ahead of time. So you don't interpret anything, you do everything up front. In your build system, you build a version for Linux and a version for Windows if you need one, but they are already in native code, which is optimized for the platform that they will be running on. So you can start at full speed, straight away, problem solved. Okay? But yeah, of course, I wouldn't be here if I didn't have a problem with this, is ahead of time is not always the best solution. It depends. It's software. There are also some backdrops. And the thing is that second compilation that makes the best code of what you need is able to adapt, to change. Again, those 5 cases, maybe you don't need that 5th one today, but tomorrow you have another use case. You're selling another product with your system, and the 5th case becomes important, then it will go back to that class file, the bytecode, and recompile it again with that 5th case. And the next day, maybe the use case is again different. So it can always go back to your original code and optimize it again, and again, and again. And that's the thing you lose with ahead of time. And again, to the person I talked to about the energy usage of your application, if you also calculate the energy spent to do that native compilation up front, has a big impact. But we still want to start at that red line, because if you have an application that does this warm up one time, okay, that's fine. But you spin up a second instance and a third instance. Each instance has to do this warm up. Every time you restart your application, it has to do this warm up. We want to start at that point. Now with Azul, we already have a solution for our licensed customers who are on Azul Prime. They can use Ready Now. We can store a profile, and with that profile, you can immediately kick in on the right level. But it's not a solution for everyone. It's not a solution for embedded. It's not a solution for, and people may be surprised by this, but never forget that Java was born on set-top boxes. It was something which was developed to build those stupid things under your television to give you all the channels that you can choose from. So still Java is used in a lot of these systems. My car has 3 Java licenses in it. And you want your infotainment system to start up the minute you start your car, not that it has to warm up. So for all these solutions, for all these use cases, we needed another solution. And that's when we came up with CRaC. Let's take a look at the timing, okay. Now the CRaC that I was talking about, the coordinated restore checkpoint, what is it? And every word here matters. Even if the CRaC seems to be a strange thing to use, it all matters. So you want from your application at the moment it is in an ideal state, it's warmed up, that you can create a checkpoint. You can save it. Of course, after you have saved it, you want to use it to restore it, to restart your application from that point. But there is, again, a problem there. You cannot just grab everything and save it and restart, because some files are open, some connections are open, like for instance your database, a file, a logging file, a network connection. It doesn't make sense to keep them open because there is no connection anymore. So you want the application to be coordinated. Your application needs to be aware, I have to be ready for a checkpoint, or I restarted from a checkpoint, so I have to restore my connections. So that's all the things that CRaC is offering you. We officially announced it in May of this year. So this is ongoing already for longer time, but we announced it as being part of Azul Zulu, and we announced also these results. And this is how you can use it. So to add CRaC to your project, you need a dependency. And if you have done that, you have two new methods that you can override. And that's the before checkpoint and the after restore. So in the before checkpoint, that's where you add a close function for your database. And in after restore, that's where you reopen the database or other things. So actually, these are the two only changes you need to do in your application is look, where have I open files, connections, sockets, and where do I need to close them and open them? So that's the only thing you need to do in your application. Now, as I said, I'm the Java on Raspberry Pi guy, so I launched this on a blog post, and I think 2 minutes later, someone asked, and does this work on Raspberry Pi? And yeah, because I have a bunch of Raspberry Pis on my desktop, that calls for an experiment. So I started writing a blog post, and as always, that takes more time than imagined. And after first attempt, it didn't work. So that was in June. It didn't work. And it didn't work for several reasons. But the main reason, and that's the technology which is used by the CRaC system, is there was something missing in the kernel. And checkpoint restore support is something which is actually provided by Linux. It's used in many use cases to close down your computer, to close down other applications. So it has to be in the kernel of Linux, and it's called CRaC. We are looking into solutions that we can also bring this to Windows, Mac, maybe even one day. And there we will need to find other solutions. But on Linux, we can use this technology to build this checkpoint. Now, they say that every developer that uses Linux at some point has to compile the kernel. This was my first time that I needed to compile the kernel. And when I did that and I applied that change, I could actually use CRaC on the Raspberry Pi, and I filed a ticket. I didn't know, but the Linux kernel for Raspberry Pi is a project on its own. And they said, yeah, looks good, it's only configuration change, let's put that in there. And where is the screenshot? They made a new tag in October, 4th of October. There are 100,000 additions in the Linux kernel of the Raspberry Pi. Who manages this project? This is huge. But this is an important fact. They made a new tag on the 4th of October. And why did they do that? Who is following the Raspberry Pi evolutions? There is a new board coming. They announced in September, 23rd of October, you can get a Raspberry Pi 5. So I immediately ordered one. Of course, it was not on the 23rd of October because it's software and hardware and everything takes longer than expected. I got this yesterday. And I was preparing for this talk, so it's still there on my desk in the package, and it hurts a little bit. So you know what I will do tomorrow. So why were they creating a new version of the Raspberry Pi operating system? Yeah, because they were preparing for this Raspberry Pi 5, and it's now based on Debian Bookworm, and it has all these changes applied. So again, trying out CRaC on the Raspberry Pi, it works. I can confirm that it works. I have, let me check the time, 20 minutes, okay. I have a little demo application to show you how to use CRaC and how it works and what it can do. It's a very stupid application because I needed something that takes a lot of time and uses memory. So I have a Jetty web server, I have a database to show you how to close and open a database connection with the checkpoint. And what it actually does, it just loads zipped CSV files and makes Java objects out of it, okay? I don't do live coding. I'm not experienced enough at the conference to do this, but so what it does is the web server just gives you a basic HTML page, some Java info, and you can link to some files. The server manager, and here you see the before checkpoint and after restore. So because of this CRaC dependency, we have some imports that we can do. So we have to register this class to the context of CRaC so that it's aware of the classes which need to be called with the checkpoint methods. And you have the before checkpoint and the after restore. So before checkpoint, it's closing the open connections of the web server, and after restore, it restores them, so it becomes available again. Something similar happens with the database. So if you start it for the first time, it opens the connection to the database. Before a checkpoint, it closes the connection again, and after restore, it reinitializes the connection. So very simple methods. You see, I didn't do a lot of CRaC-specific code in here. My CSV manager is actually loading these files with 1,000 up to 1 million records. And when it does that, it creates a data set with the file name, and for each line, a Java object is created. So no rocket science, just some illustration code here. So the idea is, if you want to experiment with CRaC, not on the Raspberry Pi, of course, you can do this on any Linux system. You can do it with this kind of application. I will share some other documentation links where you can find similar applications. Now, there are a few things you need to do to start the application to be checkpointable or crackable and restart it. So the first thing we need to do is, if we start our jar file, we have one extra command line argument. This command line argument tells the Java application, this is the directory you need to use to create your checkpoint. So in the CR directory, in this case, you will find the checkpoint after it has been created. So you start your application, it's running, you warm it up, you call all the methods, you make sure that everything is touched within your application so that the code is optimized and warmed up. In my example, I'm only doing this very fast, so I'm not using the full warm-up time. That the warm-up time, the duration depends on your application, of course, and the use case, but normally it's minutes that you need to consider. And then creating the checkpoint, you open a second terminal, and in the second terminal you call the jcommand function. You give it the application that you want to CRaC or checkpoint, and JDK point checkpoint. So it will initialize the process of creating a checkpoint in the first terminal with the running application. And when everything is finished, you can just restart your application with Java. You see, we don't specify the jar anymore, but we just say, this is a directory where you find the checkpoint, and you can restart from there. Pretty easy, I think. Now, this is my example on the Raspberry Pi. First terminal, I'm starting the application. This is a Raspberry Pi 4 with a few gigabytes of memory, so not a very heavy board. After 5 seconds, my application has started. She's not warmed up, started. Okay, the web server is available. Now, in this left browser, you see that a CSV file is loaded, and the first, I think, 100 lines are returned in the browser. This goes all pretty fast. 400 milliseconds, 700 milliseconds. These are the small files. Okay. Now, if let me scroll a bit further. Now it's loading the 1 million line files, which takes a bit longer, 15 seconds. So this is the initial time the file is called. So it loads the CSV file and puts it into memory. And for the next call, it's just using the file from memory. So we go to 8 milliseconds, because there are 1 million records already in memory, and they are available there. So now loading that data and checking the log file from the database is all very fast. And you see the checkpoint directory is still empty. Okay? I promise next time I'll bring my Raspberry Pi and do this live, but you know that things go wrong at conferences, so I didn't dare to do that. I called the method to create a checkpoint in the second terminal. So it already outputs that it's finished, but it's still going on, and now it's done. Keep in mind, creating a checkpoint kills your application. Yeah? So it's not something you do in production. I hope. And you see it's no longer available. So what did we do? We started the application, we warmed it up, we called all the methods that we wanted to call, we loaded everything into memory that we wanted to load, and then we created the checkpoint. So we waited until we were in that blue phase of the application, that red line, the ideal state of the application, and then we called the checkpoint. Now the idea is you can take this directory, and if you have a similar system, you can just copy that checkpoint to all these servers and start from there. Okay, you can even do it with other processors, but that's not the ideal use case. Now let's restart it again. Going back to the first terminal. Stop it. You've seen how fast this was? So first time we started the application, it took 5 seconds. Okay, let me scroll back. Now I hit enter, and it's there. So it is within a second, because that's the timestamp we are given, but nothing more. Now if we ask that same 1 million line file, it's immediately there. It was already loaded in memory, and with the checkpoint, that whole memory thing was saved back to a file, and the application just restarts from that point on. Okay? So you see we can make a huge time saver there, because we can jump right to that red line on the chart, and we restart our application at a much better point. For the people who start experimenting with this checkpoint directory is quite large. I mean, it contains a lot of files. The one you are interested in is dump4log, so debug level 4. It's a long file. But the goal of it is, if you have a problem, that probably means that you have some socket open, or a file open, or a database connection open. You probably will find information in this file to pinpoint the problem in your application that is preventing the system from creating a checkpoint. CRaC is still a project in development, so please help us. If you find something fishy, you have a problem with creating a checkpoint, maybe we can help you, or maybe the logging is not good, or we need to fine-tune some other stuff. The interesting thing, because this checkpoint did succeed, is that it took about 9 seconds to create. Now, where are we with CRaC? And that's again something interesting related to the OpenJDK project. CRaC is a project within OpenJDK. So that means if you go to the OpenJDK.org website and you go to the project, it's a long list. It starts here, but goes a long way down. That doesn't mean that this will become part of OpenJDK. So if you want to use CRaC, then at this moment in time, you need the Zulu runtime with that specific version that has CRaC in there. So a project within OpenJDK is an experiment, where can we go with this technology? You will find a lot of other projects there. Amber is there. Leiden, which is a similar project to CRaC, is there. These are things which are researched. What can we do with this? How can this be used? If you make a proof of concept, are people actually interested? And do they want to contribute? And our goal is to make a JEP or JEPs out of this. That's how all these projects in OpenJDK grow. If you look at the whole evolution we had in switch statements, in records, in text blocks, these were all JEPs, and most of them are related to a project. So projects become a JEP or multiple JEPs, and if a JEP gets enough support, it becomes part of the OpenJDK, and it helps us to evolve this whole Java framework and the language and offer more availabilities and more methods. If you want to learn more about CRaC, I invite you, of course, to visit the docs website of Azul, because I'm writing those together with my colleague. We have a whole chapter about CRaC, what you can do with it, how you can debug it, how you can help us, and where you can find it, of course. But there are already available systems using CRaC. AWS Lambda Snapstart is one of them. So you can even find it in their documentation. There are some mentions of CRaC in there. So what they do, if you have a jar file that you upload to use it as a Lambda function, they immediately execute it. And they grab that checkpoint. So the next time your Lambda is starting, it's not starting from your jar file, it's starting from that checkpoint. So that means that you gain the whole warm-up cycle, and you immediately end up at that ideal state of your application, which is a small application in this case, but it can already restart a lot faster. And that's where you see the benefit of having multiple instances of the same thing, but not needing to warm up that whole cycle. And the same thing now we have with databases and Hibernate and stuff like that. There are frameworks, of course, and it would be very easy for everyone if you don't need to care about this CRaC thing, for instance, related to your database, if Spring takes care of this for you. And that's exactly what is coming. So Spring, Quarkus, Micronaut, they are all working on integration of the CRaC system into their framework. So that means that what I just showed you of closing the database and reopening again, you didn't need to care about. A bit the same thing with the virtual threads. Virtual threads is great, but you probably won't need to implement it because Spring will use it for their HTTP stuff. So the framework can help you again to make profit of the evolutions which are happening within Java. Stay informed. That's a call to you. Is who knows Fujay? We have tried our best. We were at the entrance with our Fujay booth to have the podcast. It's the website for the friends of OpenJDK. I think we're all friends of OpenJDK. We have new content every day. Blog posts about Java, OpenJDK, Kotlin, all related technology. My funny experiments, with the Raspberry Pi are also in there. But you see that the Raspberry Pi allows you to experiment with stuff like this in a very cheap way. My Raspberry Pi of 40 euros allows me to do exactly the same experiments with the code that could be done on a very expensive big server or in the cloud, and that if I forget to turn it down in the cloud would cost me a lot more than this 40 euros for this Raspberry Pi. We also have the podcast. We have done a lot of interviews. I see someone here who was a victim of my interviews. We've done this today, and they will be in one of the next podcasts of Fujay. And at this point, in one of the rooms, at the same time, they are talking about certification, how you can prove that you are a good Java developer, also something that will be coming to Fujay. And after this talk, Geert-Jan and me will talk about Fujay in another room. So I invite you in room 8, I think, in 20 minutes. Okay, What's next? You can follow me on fuji.social, on our Mastodon instance. I'm still on Twitter, but don't put anything in there anymore. Fuji, of course, and docs.azul.com, where you can find information about CRaC, but also about these release notes and these changes between different versions and updates of OpenJDK and the different runtimes. And yeah, fail a lot. That's what I've done the last years, and I learned a lot from it, and I invite you to do the same. And that's the end of my talk. And my button was not clicking. You can rate my talk in the app. And are there any questions?
If you want to run the CRaC-enabled Azul in a container, I'm guessing you need to have the CRaC support compiled into the host
Yeah.
kernel.
And we have Docker instances for you. You will find them in the documentation, also docs.azul.com. There is some guidelines there how to use Docker. Reminds me I need to update it to the latest version. It's one of my Jira tasks. So we'll be there. Okay. Yeah, first.
You talked about Project Leiden. Could you compare them?
There's one thing I can definitely say. CRaC is already available. And that's, Java is very stable, it's very mature because it evolves in a smart way. We just don't dump new things in it. It grows slowly. So Project Leiden has the same goal, more or less, but it's even broader. Maybe CRaC, the JEP, will become part of Leiden, could be. But the main thing is, you can already use CRaC with version 17 and 21, and Leiden, we don't have a version there yet. So is it comparable? Definitely. But we don't know yet how Leiden will evolve and when it will be available. So that's the main difference there. Okay? Yeah.
After a CRaC restore, the JIT compiler can still continue optimizing more, right?
Yeah, and that's the main difference with ahead of time. Yeah. Your class, your jar, your bytecode is still there. And that's the main difference. So it is the same application that was running before, that was doing this whole hotspot thing and finding what can be optimized, it's all still there. So it can indeed restart. The next day you have some other use case for application, and it will start adapting again and again producing the most optimal native code for that moment in time and perform as best as possible. So that's the main difference indeed with the pre-compiled native compilations. Memory thing, I'm not an expert in that, so I cannot answer that one. Yes?
One quick check question, but do you still need to compile your own kernel to run it on the Raspberry Pi?
No. So if you, Raspberry Pi has an imager tool, the imager tool gives you the latest versions. If you take that one, then it's done. Okay. Check my website, webtechie.be. CRaC is using a Linux component to do this for you. So it's really using a Linux function to do something like that. Not calling your methods, but to get this memory dump and all that kind of stuff. So that's why you need that component in Linux. And most other Linuxes have it enabled. It was just something which was not enabled on Raspberry Pi. And how I for the first time, compiled my kernel. I'm proud of it. Yes.
What happens? So you've cracked your application, and you change one insignificant line of code, and you make a new jar. You need to crack it again.
Yes.
Okay, so everything it's strong. It's exactly related.
It could become part of your build process. Let's start this application in the right infrastructure, call all the functions we need, and then create a checkpoint, and then use that checkpoint to deploy it in our infrastructure. It's just one option. Yeah.
I'm just wondering about how snapshotting works. If I put it as a part of my Docker build image, I'm like building my service, I'm like heavily loading it, then I make a snapshot, but then it makes a snapshot using Linux kernel snapshot. Which to reduce all the memory pages. That means if I set memory limit of my servers up to 2 gigabytes or 4 gigabytes, then I will get 4 gigabytes memory dump. That means I will get 4 gigabytes Docker image where for my stuff. So is it possible to optimize it?
Probably, but I said I'm not. I didn't create this, so I'm just a very enthusiastic user. I think if you check here, then you will find more information about the Docker usage. Usage guidelines. I think the Docker stuff is in here somewhere.
Because I can imagine that this will create huge Docker.
They will be as huge as your initial Docker could be. So if you assign it this amount of memory, it can use this amount of memory. Then your Java application will not go higher than this. But it's not. I cannot answer you this one, so I will leave this one to the experts. But join the project on GitHub. I think we have to finish. Join the project on GitHub. There are questions you can ask. My colleagues of Azul who created CRaC are on there, and they're really waiting for your answers because they want to make this the best possible solution for everyone, and they're really eager to help you for that. So we have to close down, but thank you a lot for your attention, and I invite you in room 8 if you want to learn more about Fujay. Thank you.